what we're going to do is we're going to solve this word problem. As I said a minute ago, you don't have to generate this problem now. If you wait, when you get to physics, then you would be able to take a word problem, make it into a quadratic to solve. But for right now, we're just giving you this quadratic and you're going to solve it. So first thing that we need to do is, this is still the 13. What happened? What did I do?
You subtracted 16.
26.
Subtracted the 26 from both sides, and when you subtract the 26, it brings over the linear term. The 26t is already here, but when you have a quadratic equation, you always have the part with the squared first. So this is negative 13 halves t squared plus 26t minus 26. So the only thing that happened to go from here to here was subtract 26 and reorder it a little bit so that it looks a little bit nicer. Alright, so what we should do then, if you're solving it using quadratic formula, is we should identify A, B, and C, right?
No.
So, I know that this is a lot to come up all at once. A is negative 13 halves, B is 26, and C is negative 26. This is from yesterday. Then we plug all those numbers into the quadratic formula. So T is going to be negative B, negative 26, plus or minus the square root of B squared, this is a 26 squared, minus 4, it's always 4, minus 4, A, negative 13 halves, C, negative 26, over 2 times negative 13 halves. It is kind of crunched in there, but all of the parts are there. If you've identified A, B, and C, even if you're having trouble reading the handwriting here, you're plugging it into quadratic formula. So this is B, this is B squared, minus 4, there's your A, there's your C, and there's the denominator. Okay? So let's take a look here. 26 squared, that's pretty easy to do. This is a negative times a negative times a negative. So what are you expecting in the negative? Minus, right? And these 2's are going to cancel out, so it's already going to become much simpler very quickly. So let's take a look here. Here's my 26 coming down. 26 squared is 676. When you multiply this all out, believe it or not, we also get 676.
Wow.
Okay, so this is actually kind of a nice problem, because this one came out to be 676, and so did this. This came out to be negative 13. The 2's canceled. So what happens? 676 minus 676 is how much? 0. How much is the square root of 0? 0. That's this right here. Square root of 0 is 0. So you're adding or subtracting 0. That's the same problem. There isn't 2 problems here. There's really just 1. So 26 13ths is 2. Okay, so this one, even though it looks really complicated to start, if you plug in, if you don't like doing the 13 halves, turn it into a decimal. 13 halves would be 6.5. So you could do negative 6.5 if you wanted to. The good thing about quadratic formula is all you're doing is just taking your time, plugging in numbers. This right here came straight from the calculator. 4 times 13 halves times 26, and get that number. They do cancel out, and you end up with 2 seconds. There's not even a choice on this, because negative 26 plus 0 is negative 26. So is negative 26 minus 0. So this one, even though the problem looks like, oh, we've got a lot of words and things like that, when we actually bring it down and solve it, it's not really so bad at all. Okay? So that's just our one little word problem application so that you've seen it, so that you know that this is where you're going with this when you take physics eventually for those that are going to do that. Okay? Is there anybody still working on that?
Me.
It's racist.
Okay. Unpause. There we go. Moving right along. This part right here of the quadratic formula is special. It's called the discriminant. Where do we find this in the quadratic formula?
Under the square root sign.
Under the square root sign. So, depending on what value you get for just this little piece of the quadratic formula, it's going to tell you what kinds of solutions to expect. And part of what you're going to be quizzed and tested on is using this discriminant to tell you what kinds of solutions to expect even before you finish out the quadratic formula. Okay, so this right here, known as the discriminant, can be used to find out what kinds of solutions. All right, and I'm just going to add things down. Now, first, one of the possibilities is that this is a positive number. When this comes out to be positive, and you're taking the square root of it, okay, we don't have imaginaries to deal with. It will mean that you'll get a plus or minus, so you'll end up having two solutions. So anytime that this is positive, you're going to end up with two rational roots, or two real roots, not necessarily rational, but two real roots. Now there's a couple of different varieties that you could get. The first one, and this is a little chart so you can tell him, you're going to be asked on the quiz, on your homework, to do this, to tell the nature of the roots. So if the value of the discriminant, in other words, you figure this number out and you get a number bigger than 0, and it's a perfect square, what you're going to find out is you get two solutions. They're going to be real solutions, in other words, no imaginaries, and it will be rational. Okay, remember rational means it can be written as a fraction. And the nature of the graph means that how many places does it touch the x-axis? It will intersect the axis 2 times. It'll be your parabola, it'll touch the x-axis twice. So on a quiz or a test, you could be asked to calculate the discriminant, in other words, find the number, and then tell the nature of the roots and possibly what's going to be true about the graph. So the nature of the graph, when it's a positive number, greater than 0, and is a perfect square, means you're going to get two real rational roots. Okay? You can also have a positive when it's not a perfect square. Now if you have a positive number under that radical, positive discriminant, and it's not a perfect square, how many roots will you have then? Two roots again. But that would be the type where you try to reduce the radical and it doesn't come out right and you get that really long decimal if you put it in your calculator, or you have to simplify the radical. So instead of rational, it would be irrational. Yes.
Oh, never mind. You guys are never mind.
So if it's not a perfect square and it's still bigger than 0, that means you get two real irrational roots. And once again, it crosses the x-axis twice. Okay? Now, on your test or quiz, and I'll show you in a minute some examples of these, you calculate the discriminant and then you give the nature of the roots that goes from, you use this chart to figure it out. Okay? what's another possibility? It could be greater than 0, or it could be
Less than.
or it could be
Equal to.
equal to. So we need to take a look at what happens in both of those cases. So if it's equal to 0, perfect square, well, it's 0. Technically, I guess it is a perfect square, but we kind of ignore that question. That's where you just get one real root, because you're adding or subtracting 0, and it only touches the axis once. What was your question?
Oh, I couldn't understand your handwriting or something, but I figured it out.
Okay. So if it equals 0, you get one root, it's real, and it touches the x-axis just once. Nope. It's just, it doesn't apply. Okay, perfect square, we're just ignoring that. So.
Wait, is it one real rational root?
Just one real root. Okay. Now, if it's less than 0, can it be a perfect square?
No.
No, it can't even be a perfect square if it's negative.
It's not a rational.
The nature of the roots, if it's a negative, that means that when you have a negative root, that means you bring the eyes out, right? You have imaginary numbers.
Pop it out.
So you wouldn't have 2 real roots, you would have 2 imaginary ones. Where will it cross the x-axis? Not at all. So if it's less than 0, you'll have 2 imaginary roots, and it will not cross the x-axis at all. If you tried to graph it, you wouldn't be able to solve it by graphing. So the value of the discriminant tells you what to expect from your answers. So if you find yourself not sure if you're going to get an I or not, examine the discriminant. And that's going to be able to answer a lot of your questions as far as what you're expecting. So our next thing that we're going to do is we're going to take a look at calculating a bunch of discriminants and giving the nature of the roots. We just talked about what they are. And so kind of keep that chart handy so that, you know, you keep your finger in your notebook where it is, so that when you go back and you look at each one, you're going to be able to tell what the nature of these roots are.
One minute.
Okay. So no x intersections. All right, here we go with our next question. Our directions, your directions would say, find the value of each discriminant and describe the nature of the roots. We're going to do 4 of them, and they are all going to end up on the same screen here, so they'll be easy to see and compare. So we're going to look at this first one, and we're going to calculate the discriminant, b squared minus 4ac. So you still have to identify a and b and c. Giovanna, what's a? What's a in this one?
At 1.
1. And what's b, Grace?
Minus 8.
Minus 8, good. And c, Preston, is
16.
16. So you're going to take those numbers. It's not as difficult because you're just doing this little piece of it, just plugging into this. So we'll take those numbers. Here's our b squared minus 4 times 1 times 16. Now the great thing about these is you can put them into your calculator in one step if you want and just get an answer. So you put that into your calculator. And we find out that this number comes out to be 64 minus, how much? 64 minus 64. So the answer is 0. From your chart, if it's 0, what are the nature of the roots? One real root. So 64 minus 64 gives you 0. The answer is 0 is the value of the discriminant. There's your first answer. And the nature of the roots is 1 real.
I like this.
Good. So all you're doing is figuring out that and then evaluating what that means. Okay, let's look at another one. 5x squared plus 42 equals 0. Why do I have a 0 here? Which is this? This is A, B, or C?
It's B.
B.
Oh, there's no B.
So there is no x term, so that's why this one is 0. So 0 squared minus 4, it's always 4, times A, 5, times C, 42. Okay, so in this case, it works out like this so that you do have a 0 for your B. Now, when we evaluate that, you are going to get a negative number. We're going to get negative 840.
So there would be 2 imaginary.
Beautiful. So the discriminant is negative 840 and there's 2 imaginary roots because it's negative. The negative from your chart, less than 0, tells you there's 2 imaginary roots. And you're done. This is the value of the discriminant. It's not solving for x, it's just the value of the discriminant. And the discriminant will tell you how many values you're expecting. Okay? Alright, let's look at another one. Okay, here we have x squared minus 5x minus 50. Took the liberty of starting it here a little bit. Negative 5 is B. 4 is always 4. 1 is A. And C is negative 50. So 25 plus 200 minus negative makes plus. Plus 200 gives 225, which is
2 real or rational.
Is it rational or irrational? Is 225 a perfect square?
No, 2 real irrational.
It is a perfect square. 15 squared is 225. How do you tell on your calculator if it's a perfect square if you're not sure? Square root. And if the square root comes out even, you say, oh, okay, it is. Okay, so 225 is actually 15 squared. So that means there's 2 real rational roots. 2 real rational roots because it's positive and it's a perfect square. Okay, and then we have this last one to evaluate. Okay, and in this last one, A, B, and C. What's A?
Wait, what is that?
Negative 2.
A is 2, B is,
Negative 9.
and C is 8. So you're going to plug it into B squared minus 4AC. Negative 9 squared minus 4, because it's always 4, times 2 times 8. We evaluate this, 81 minus 64 gives us 17,
Which is irrational.
which is not, it's not a perfect square, but it is the discriminant, so that's half of our answer. The other half of the answer is what?
2 real irrational.
2 real irrational. Because it's not a perfect square tells us you have 2 real irrational roots. So this might be a little bit easier for you when you're looking at your notes to evaluate based on this example. So if it's 0, 1 real root. If it's negative, 2 imaginaries. If it's a perfect square, it's 2 rationals. And if it's not a perfect square, 2 real irrational roots.
Right.
Yep.
Okay? So that's how that goes. You are prepared now to...
Now we have a test due tomorrow.
No, test
Don't
just
even.
for Preston.
Pop test.
Just for Preston.
Just for Preston.